Imagine you get stuck while traveling in the middle of a sea or deep inside a mountain range. How will you describe your location to a rescue team that is set up to find you in such a way that there is no confusion? You can use a spherical coordinate system known as latitude and longitude. Just like a planar coordinate system, we need an origin or zero reference, and we measure away from that origin in two directions. Here, the x-axis lies horizontally and the y-axis lies vertically, and both passing through the zero of the other. Any location on the flat page or screen can be uniquely located by how far to the left or right it is of the y-axis and how far above or below it is of the x-axis. To locate ourselves on the surface of the planet, we need a similar method of coordinates, but the challenge is that the Earth's surface isn't flat, it's basically a sphere. Though not even that is perfect, as it's a bit egg-like as well. But for our purposes, we'll work with the perfect sphere idea, and we are going to use circles. We break the planet up into equal-length circular lines of longitude that run from North Pole to the South Pole, east and west of the prime meridian. Anywhere along a longitude line, a point is an equal angle of a circle away from the prime meridian. Since a complete circle is 360 degrees, half of one is 180 degrees and 1/4 is 90 degrees. If we travel 1/4 of the way around the planet west of the prime meridian, we have travelled 90 degrees west longitude. If we travel 3/4 of the way, it's the same as travelling 1/4 east or 90 degrees east. If we travel all the way to the opposite side, we are at 180 degrees east or west. So even though 90 degrees of western arc travel is much smaller near the poles than it is at the equator, we can still accurately locate our east-west position by an angle measurement of longitude. Now, let's add in the other coordinate, the position north or south of the reference, called the equator. We can generate equal interval circles that are parallel to the equator and appear north and south of it. We call these latitude because they run east-west or side-to-side laterally. However, we use them to determine the angle along a circle that we travel north or south of the equator. For example, if we travel to the North Pole, we have travelled 1/4 of a circle away from the equator or 90 degrees north latitude. The South Pole is at 90 degrees south latitude. Halfway in between the equator and the poles we travel 45 degrees north or south. Now, pause the video and test your understanding by accurately locating points A and B as shown in this image. Now, try to accurately locate or place a dot on the spot that is located 45 degrees south of the equator and 45 degrees west of the prime meridian.